Hello coders, in this video we will see the next question from our LeetCode 75 list, and let me take you to the screen first. And yeah, here. So this is the question, which is successful pairs of spells and portion. You are given two positive integers array spells array. Okay, sorry. You are given two positive integer arrays spells and portion of length m and m respectively, where spells I represent the strength of ith spell and portion I represent the strength of jth portion. Okay, you can ignore it, like if you don't understand, doesn't matter. We will understand what basically question saying. You are also given an integer success. A spell and portion pair is considered successful if the product of their strength is at least success. Okay, so product of the spell and what portion. Spell is in first vector, portion is in another vector. We need to do the multiplication, and then the if that multiplication is greater than the success, then we will consider that this successful product. If just greater than or equal to, spell portion is considered successful if the product of the strength is at least means greater than or equal to the success, then we'll consider it is as a successful product. Return an integer pair of length n, where pair size is the number of portion that will be successful pair with ith spell. Okay, so what they are saying, we have spells. For each spell, what we need to find that how many product I can get from the portion, so that their product will be the successful, like the product will be greater than or equal to success. So basically that need to find. So yeah, let's take the first example. Here, this is the first example, which is this. And okay, first we have 5, and then when we multiply this with all portions, then we get this thing, that 5, 10 and 25. Okay, I'm multiplying 5 with 1, that is 5. I'm multiplying 5 with 2, which is 10, 5 with 3, 15, and likewise. From this, how many products are greater than or equal to 7? 10, 15, 20 and 25, because 5 is less. So 4. Then what we have? We have 1. 1 multiplied with any 1 is 1 only, so we'll take this. And do we have any product which is successful? No, I don't see any number greater than 7, so 0. Then we have 3. Okay, then what we'll do, we have to multiply this with 1, 2, 3, 4, 5, and we'll get this product. 3 multiplied with 1, 2, 3, 4, 5, 3, 6, 9, 12, 15, and how many of them are greater than or equal to 7? Is 9, 12 and 15, so we have 3. So we need to return what? We need to return these answers basically, which is 4, this 4, the second one 0, and the last one 3. Okay, we'll return this. That's what they are returning. Okay, so how we did it? Like we took one spell, we multiplied with every portion, and while multiplying we we did what we did. We just incremented the count. If it is greater than or equal to 7, I'm not 7, greater than or equal to success, then we consider that as successful product, and we incremented the count, and we just push that count in the answer vector. And likewise we did this for every spell. Okay, so this, if I do this like what I said, then it will take big of n square time, because let's say n, we have n spells, we have n portion. We'll take one spell and we multiply with each portion, which is we have n portion, and likewise for n spells we need to multiply with n portions, and we will end up with n square times complexity. But is it accepted? Like, will it get accepted? No, because n and m is greater than or equal to or less than or equal to 10 raised to 5. So basically it can go raised to 10 raised to 10 raised to 10, and which will give us time limit exceeder. So what we can do here? We have portions. What if we sort the portion? Like yesterday we saw a binary number in like binary search. Can we use that here? Yeah, we can use that. How? Just let's sort the portions, cause we will require the sequence of spell, but we just for the portion we just require count, so we don't require it sequentially. So what we will do, we will sort portions, and what will after sorting the portions, what we need to do. Okay, we sorted portion. We have a spell. If we start multiplying from first portion, like now it is sorted from increasing order, and we started multiplying it, then what we can see here, the point from which the multiplication success, like successful multiplication, the product is greater than or equal to success, the point, like the index I am getting, from that onwards, all the numbers, like if I do multiplication with this number, with this number from cell that I took, it will result in greater than or equal to success. Why? Because basically it is in increasing order. So if I'm multiplying, like if I took x from spell and cross y from portion, and it is greater than success basically, then the number which is after y, I will take it as a z, and I will do multiplication with it, like x cross z. Then as y is greater than z, so x cross z also, it will result in greater than yes. So basically we got the index on which, like afterwards, like on that, after that index, like will not do the product. We can just say ki, okay, n minus this index, that those much successful product I can get. Okay, so now for that index, that the index I found, what I can do, like can I find it using, like can I find it, like if I do the linear search, I'm getting it, like I'm just multiplying with first number, second number, third number, like this I'm finding the index over the number, index basically, index on which I'm getting the successful product. But can I do this using something else so that I can get it in a less complexity? Now it is a linear, but I want it to be in less time. Yes, I can do it in using binary search. For the binary search, what I will do, the low one I will take the like first one index, and the high one will be the last one index. We'll take the middle index. Then the middle index we will do the product, and we will see, oh, this product is greater than the success or less than success or equal to success. If it is greater than or equal to success, then yeah, from that index onwards I can take any index. Okay, so what if I do have an index before that index also. Okay, then what I will do, I will assign that mid to the high, and I will then, like basically I'm doing I'm dividing my search space here. So likewise we will find the index. We will, like to find the index, we will do binary search, and after I get the index from onwards, which I'm getting products greater than or equal to success, that one, like n minus that index will be the answer for that spell. So yeah, that's what the explanation will. Now we will do will code, and yeah, let me take you the screen again, stop, and now. So yeah, whatever I said, we'll do that only. First, what I want, 1 minute. What I want key, I want to return the answer vector, so I will say this is my answer vector, and for each spell I will say int spell 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 from spells. I will take the spell, and now what I want. Okay, I need to, what I said key, I need to sort the portion also. I need to sort first portions, then and then only I will get the index, like required index. For the binary search, keep in mind key we where on whatever vector we are applying binary search, that vector need to be sorted. So we will sort the portions basically. Portions dot begin and portions dot sort. We sorted it using what? We sorted it in increasing order, and we'll take the portion size, portion dot size. Okay, here is my portion size, and I will take int low is equals to 0th index, to high is equals to n minus 1th index. Okay, while my low is less than or equal to high, I need to find index. So what I will say ki I need to find a mid, or I will say I need to find what? I need to find that index. I'm saying ki index is equals to, or now I will say it is -1, cause what if I will not get any index, like all the numbers in that portion, if I multiply that with the spell, I'm not getting any successful product. So that's why I said ki index is equals to -1. Then what I will do? I will take a mid index, which is low plus high minus low by 2, and it's mid, not mod. I will check if the portions at the mid index cross spell is greater than or equal to success. I will check it. If it is greater than or equal to success, then what I will do, okay, it is greater than, so I need to find the lesser index for that. So I will say high is equals to mid -1. Otherwise, I need to find the bigger index, because I want to find a big portion basically. So I will say low is equals to mid plus 1. Okay, and while doing this, what I will do, till mid I know it is greater than or equal to success, so I will store it in index. So before storing it, what I will do, I will store the minimum index. So for that, if I do this, what I will do here, I will basically say just it is n, or let's say n plus 1, which is will not exist, and here minimum of that index and the mid. Okay, I want minimum index, so that when I do n minus that index, I will get a largest portion, in which we have numbers whose product with the spell is greater than or equal to success. Okay, we have this now, and what I will do, I will check if index, okay, not in this. This process will continue till low is less than or equal to high, and what I will do at the end, if index not equal to n minus 1, sorry, n plus 1, not equal to n plus 1, n plus 1, then answer dot pushback n minus that index, else answer dot pushback 0. We don't have any number, any portion. So I will return the answer error and just run it. What it's saying? Oh, extra. Then submit it. Oh, what is saying here? Okay, multiplication is greater, as it is, as we can say, it is a long success. It will be stored in long. Okay, I can do that and submit it. So it is accepted. And what the time complexity for this, as we can see here, if we have n spells, I'm saying spell size, okay, bigger n, like capital N, and this for loop will run for n times. And if we have portion size is capital M, so then this will be run in log m base 2. So the overall time complexity will be okay, I just write TC is n log m and the base 2, and the space complexity here, to get the answer we use big of n space complexity. And also, okay, 1 minute, this is log m, either this or the maximum of, basically we can say the maximum of n log m or m log m. Why did that? Because here we can see, 1 minute, let me write it in good manner. Okay, maximum of this. Why? Because we are here, we are just sorting portions, so it will take m log m time, and for this taking n log m, so maximum of this will be our time complexity. And the space complexity, we have to return the answer, we have used big of n space, and back other we have just big of like constant time complexity. So we can say the time space complexity for this is big of 1. Okay, so yeah, that's it for today's video. And if you liked my video, then like, share and subscribe. We'll meet in next video. Till then, bye bye.